Good morning, everyone. Welcome to today's webinar. Our recording today is on the FDOTSS4 crossover detail modeling at intersections. And we're going to cover some of the techniques and ideas for modeling out the normal crossover, obviously, locations at intersections. This is according to the advertisement for today's webinar. We'll be discussing methods for designing and modeling the pavement slopes at intersection crossover locations using the OpenRoads technology, and techniques will be shown for both intersections, open intersections and restricted turn lane type intersections, similar to the image that was previously on the screen. I don't have too many slides. I never usually do, but I usually like to have at least some steps to follow. And we're also creating indexes with our recordings now, so this helps for indexing the video so that you'll know where to go to see that particular step in the recording. It's really pretty straightforward. For an open intersection, one that doesn't have any restrictions on it, the typical workflow is going to be you'll need to add in some reference lines, and we're using the feature pavement slope break. And usually those go from nose to nose. And this type of modeling isn't necessary when you've got a balanced crown intersection. You know, your median just stops and you're crowning to the middle. But whenever you add turn lanes, opposing turn lanes, left turn lanes, you'll need to provide this intersection rollover because the crown won't be straight down the middle. You're going to have to transition from one side where the slope is either high or low to the other side. And that's where these reference lines come in. And that's what it means by placing from nose to nose. And I'm going to do that a couple of times when I get into the software. You'll know what that is about. The second step is to configure or edit the template crossover median components. And I've included 3 screenshots that are going to at least document the point property modifications that you need to make. There's just 3 points, and we're going to go through that live as well. Once you've done that, then you'll just add corridor references, which are your pavement slope break lines that you added in step 1. The corridor will reprocess, and the crossover median will then have a rolling crossover from one nose to the other. The other thing is usually some detailing at the nose area of the model, the traffic separator nose, or if it's a curb type nose, you'll need to remove any corridor references you used off of the nose elements. And then we're going to use linear templates and civil cells to build the actual detail of the nose, mainly because the nose is never perpendicular at any location to the center line, which is where your corridor is based on. And then lastly is to check the rollover slopes, and that meaning the crossover rollover slopes, where it goes from a 2% to whatever it needs to based on the width of your slope break lines. You just want to check those to make sure you're not violating the rollover or the cross slope break adverse crown condition. And that's basically what the steps are for an open intersection crossover. As far as a restricted left turn or restricted movements in an intersection, there's a few more steps after you've done the open crossovers configuration from the first few steps in the previous slide. And I'm going to demonstrate some of this. Some of it I already have set up. The first thing you'll do is obviously add in a restricted turn lane elements. We actually have a civil cell for that. I'm going to demonstrate placing that civil cell. It doesn't work on the one project because the median isn't wide enough on this project, but at least I can place the 2D elements. From there, you're going to create profiles along the lines. Essentially all of the lines that make up the restricted turn lane. That would be the curb lines, the traffic separator lines. And you do that using the quick profile from Surface Tool in OpenRoads. I have an asterisk here that says use the top mesh terrain. I'm going to discuss some of the issues with this command right now, but you can still build profiles from it. from using that as a reference. Once you have those profiles on each of those elements, then you can use the curb components to place linear templates where necessary, that is on both sides of it. You can edit the linear templates at curb flare-outs. Sometimes, I'll refer back to this previous picture, sometimes up in here you might have a flare-out here. I can't zoom into this location here, but where the curb goes into a shoulder, there might be a flare-out. And you can edit a linear template in here and actually have it follow the curb backline and the curb faceline to make it transition out. You can also put a parametric constraint on the actual component itself to drop that if you want to flare it down to 0. And so that's essentially what you're doing. You're just placing linear templates around these elements, both sides. You place a linear template along one side of your traffic separator and use the traffic separator component, and then just use a point control on one side. Do the same thing as far as the nose. You can use a civil cell for that. And as far as building these median areas, if you just select the two top of curb lines at the back, you can actually create a train between those two and fill in the details with sod or concrete or whatever method you want. And then lastly is clipping where desired and when desired is really a better when desired. Clipping usually adds a lot of overhead to your corridor processing, so we recommend you do that at the end if you decide to do that. But I'll show you what the cross sections look like without it clipped through those areas, and then you can basically go from there as far as what it would look like to clip it. And I think that's all the slides I had for now. I'm going to come back to these configuration slides as far as the point properties. And let me get into a session now where I'm going to actually place one of these transitions. So I have a couple of locations here. I've got a location here where I've got the traffic separator. In this case, there's no traffic separator on the opposite side. And you might ask yourself, well, why would I need to do any crossover detailing in this area? Well, it becomes very evident when you look at the actual model itself. So here's the model, and there's the traffic separator coming into the normal crossover situation. And if you look, you'll see that the normal crossover is going to try to crown in the middle, but yet on this left turn lane, it's sloping up to meet the traffic separator. And there's no way that these two are going to meet. So what you've got to do is put these slope break lines in here. And if you can see them in the model, and these models, these points are actually in the template. But before we do that, let's just go ahead and the first step is to place the slope break lines. You can do this with a normal place line tool if you want, or you can do it with the single offset partial element tool using a transition method. I'm going to do it with both, and I have two different intersections. So I'm going to just place a line, and I can start it at a tangent to the nose that's currently here, or I can snap to the end of the nose, to the end of one of these tangents. Either way, it's really up to you as far as how detailed you want to make this, because obviously a tangent from here would go across the nose. But I'll go ahead and snap on that point anyway. I'm just going to go to a key point snap and place a line. And I'm going to be careful to make sure that I pick the pavement slope break from the features list. So I'm going to go into the 2D plans, find the pavement slope break feature. And I'm just going to snap to this point. And now on this intersection, just because I think I know how I want to design it, I'm going to let it transition in 200 feet. So I'm going to set the length at 200, and then I'm going to eyeball it. And what I want to do is tie it into the center line on the other side, the center line of my actual corridor, because right now it's sloping up and it's basically not on the center line to that side. So I'm going to basically place it in here and just essentially set it right there. And then I'll add the other slope break line from the other side, and I'm going to snap to the end of this other point here. Okay. So now what I've done is I've placed these, and this feature is actually a construction class element, so you don't have to worry about it plotting. If I hit my F7, actually I thought it was. Oh, it's a set to a DP level, that's why. so you don't have to worry about that. It won't print DP levels. All right, so that's all you really need to do as far as laying out how you want it to transition. The next step will be to edit the crossover component in the template. So you go to the template library, and for this particular project, I'm using this State Road 61, and if you've used our common crossover components or used any of the ones that we've built, you're going to see that there's 3 points in here in the crossover. Well, there's the 5 actually. There's the 2 attachment points at the PGLs, and then there's these crossover controls. I'm going to go back to the slide and show you the actual point properties that you're going to edit. So this is editing this first crossover point here. And what you want to make sure is that you've got a pavement break PM feature used, because it's actually going to place a line in the model. And then you're going to set the first horizontal constraint at a whatever distance, and it's coming from the actual PGL endpoint. And then you'll have to make sure that you have a horizontal feature constraint looking for the pavement slope break line to the left, or a positive 40 feet. My median is, it's not even that wide, but I just put in 40 feet for now. And then the other thing you're going to do, because this project has super elevation, is you want it to follow the slope as it moves up as the same as it would if there was a traffic separator or a left turn lane, in that case on the opposite side. And you'll want it to follow the vector of the roadway. So that's why it's a vector offset between this outside point and the inside point. That way, if this road becomes super elevated, the slope will follow it, obviously. And then you'll do the same thing on the right side. Basically the same thing, check the same thing. You're going to be looking for the slope break to the inside, this case, and it'll be a vector offset. And then lastly, the pavement crown point in the middle, again, it will need a pavement slope break feature. However, you're going to constrain it so that it starts, this median point starts at a distance from the left crossover point, and what you want it to be is a value, or a calculated value, which is halfway the distance between the right crossover and the left crossover. So that's why there's an equation here, and if you hit the equal sign, you'll see that it's between 2 points times 0.5. That will set the distance to locate the middle point of this. It really never will be crowned, it's just a middle point on there. And then this is going to be a vector offset between the left crossover and the right crossover. So you want this point to be right in the middle, because what you're essentially wanting this thing to do is rotate this slot up, and you want the crossover to roll with it. So you kind of want that to lift up. These screenshots will be posted with the recording, so you'll be able to download it and have it for your records as far as setting these things up. So default, we deliver them as set up, you know, just as normal slope and horizontal from one side to the other. So I'm just going to make sure I set these up according to the way these slides are. And so this is set to, this really you don't need to change. You do need to make sure that you have the pavement slope feature here, pavement slope break. Actually, you want the underbar PM one, pavement break PM rather. And apply that. Then you're going to change this to be a vector offset, and it's going to go from this point to obviously this point. Make sure that's set to 0. Check a horizontal feature constraint, and this is where you're looking for pavement slope break. So set this up, pavement slope break, and set the distance to 40 feet. So you've done that on one side. I'll do the same thing on the right side. This is the horizontal location is good. Set the feature to pavement break PM, and then set the horizontal feature constraint and the vector offset. Vector offset from here to there. Set the range here to -40. Choose apply, close. Then the last point we need to modify is the middle point. And the middle point will be, again, pavement break. It doesn't have a horizontal feature constraint. You don't need these labels. And what you're going to do is you're going to set it to begin with horizontal, and you're going to pick it from the crossover point, and then you're going to set this to a value which is the difference between the right control and the left control, and multiply it times 0.5. That'll basically put it in the exact middle between those 2 points. And then this will be a vector offset defined between the 2 crossover points, crossover controls. And you'll set that value to 0. Now, the way this then will work is as this feature finds itself in the plans, it's going to basically move this from one side of the center line, or basically as from one unbalanced location from the center line to the other. So you can see how the median actually rolls with the definition of where that point location is. The same thing on this side. So if the two sides are moving together, this is always going to slope up according to the slope of this roadway, and obviously the same thing, and it will adjust that crown as necessary. And that's why you see, dependent upon where these lines are, you're going to want to check this break of this, and you may need to widen these lines out or add some additional points in there to control that crossover a little better. And I'll show you some of the techniques for that as well. So once you have that set, save it, and then synchronize the template so that the corridor can accept the changes. And then you'll select these 2 lines here and add them as corridor references. So I'll select this line, and I'll go to the Add Corridor References, and I'll locate the corridor, and it says data point to apply to references. And now you'll see that the crossover has been added in there, and this pavement actually slopes up to that location, and it will eventually come back to a crowned location back here. Now I can change the design stage to make this look a little more detailed. I'll go from preliminary to final, and obviously you're going to work that out better as far as that little detail, that gap there. But what I do see is my traffic separator now is landing. It's basically going to slope this pavement up, and if you wanted to check a cross section there, you can just go to the locate station via data point and pick the corridor, and then pick a location here. I'll just do 71420. And then pick a view. And you can see the crossover there at that particular location. So as one side's rolling up, and this is kind of showing it rolling down. I'm looking at the opposite direction, obviously, and this is where I was saying you can check the actual slope there. So I can place a temporary dimension line and place temporary dimension line. Go from here to there and view that slope. So that's 8.9%. So what you could do is you might have to widen these out a little bit, or adjust your super elevation or profile grade lines in order to make that meet standards. That's one way to do it. So let's go look at another location here on a curve. I placed just tangents. So here's a situation where I've got these two curb medians and opposing left turns, I could do essentially the same thing, but instead of using the line between points, I'm going to use a variable offset taper from the center line. So I'm going to pick the center line as the offset line, and then I'm going to snap from one point here on one side of the nose, and I'm going to go to this point over here. The reason I'm doing this is so that it stays curvilinear, and then I'm going to basically do this same tool again, and I'm going to go off of this line and click here, and then click to this other side, and then I'll just add in these as corridor references to this corridor. Before I do that, let me zoom out to this crossover. See how this is now the same deal with the crowning there? So as soon as I locate the corridor, it's going to reprocess those slope break lines in there. And now you see that the pavement is rotating itself up. You can see this this is the 2% slope up on one side, and in this location it's actually in the curvature, so obviously the super elevation is being applied forward and backwards there. So then what I'll need to do is cut a section through here. So I'm going to locate via data point and locate this plan element. Choose end there. Just cut a section through here. And you can see that the crossover is now, it's being transitioned from one side of the super with that lane to the other. Okay, so that covers how you would add them in there. Now let's say I needed to modify these a little bit. You can insert points on these things. So if I go to just insert a vertex, I can insert a vertex on this line. Well, I might not be able to do it on one of these linear transition lines. But if it was a line between points, you could insert vertexes if you wanted to modify that out. So you can insert a vertex here if you wanted to let it stay a little, you know, just kind of widen out that transition a little bit. It will process the corridor, and now that slope line will be adjusted in the model accordingly. I think I might have done a reset there. So that covers how to add the crossover transition lines in there, the slope break lines. Now let's talk about how you can model a couple of these detail areas. The traffic separator nose is pretty straightforward. As you can see, if I hover over this, this is not added to the corridor as a reference. However, these two sidelines are. And as a matter of fact, if you're going to use the traffic separator nose civil cell, you don't necessarily need this. It's an extra element in there because the traffic separator nose civil cell will actually place that line in there. So what I'm going to do is I'm going to add this in here real quickly. It doesn't have a profile yet, so the way you get a profile on this element is to do it from the 3D element. So I can use the vertical geometry tools. So right now I'm placing the traffic separator nose, and I need to first have profiles on the two traffic separator elements. Okay, so this traffic separator, as you can see, cruises all the way down there. So it doesn't currently have a profile, so I'm going to do it by 3D element. And I'm going to locate the element to profile is going to be this traffic separator. And then the element that defines it is actually in here. I may not be able to get it. It's actually this little line right here. And I've had trouble with that view. So let me just clear out of there. So the line that I'm going to use for the profile is this 3D line that's out here. So I'll go back to the vertical geometry tools, find the profile from 3D, select the line that I want to profile, and then select the actual 3D line out here. And then it's actually regenerating the corridor for the time being. and it'll come back and give me that profile. So this line now has a profile. As you can see, active profile exists in the middle of this call out. And I'm going to do the same thing on the other side, but I'm going to make sure this view is rotated first so that I can see the line. Another way is to turn off all these, this pavement shape if you wanted to pick that line a little closer. But then I'll go back to this tool and I'll select the line I want to profile as this one that doesn't have a profile. I'm going to use this 3D line here, and it will generate the profile for that 2D line from the model. Okay, once they both have profiles, then you can use the civil cell for the traffic separator nose, and that is in the intersections civil cells. Once the dialog opens, there's the FDOT intersections, and out here is a traffic separator nose. Choose OK. And it asks me for the traffic separator, and the first line that you want to select is the left side of the traffic separator in the direction of travel. And then it wants to know where the other reference line is, which would be the right side. And then sometimes it tries to place it on the opposite side, so you need to change the references by clicking on the elements, change the orientation, and it will slide in the traffic separator nose there. And if I zoom out and reset and accept, the traffic separator will get built in there at the end of it. The nose will. If I zoom in here, you can see the traffic separator nose is in here. Now sometimes the profile, it doesn't catch the profile, but you can simply edit it by clicking on here and going to the profile view. And if you click in this view, you see this is the profile that it was trying to get from those 2 points. And if you need to adjust it, you see the direction of the nose. It looks like it's going from the left turn side, which would be this side, to around to that side. So sometimes what I have to do is, or what I suggest you do, is go into the vertical geometry and try to use the profile intersect point tool. And then the element that you want to show intersections, the errant one apparently is on the left side. And then I tell it that I want to show this profile point and reset. And even then it sometimes doesn't want to draw that. So another way that you can do it is to actually, it's because this line has a profile point. If you go to this profile here, actually it's this line. The reason it's dropping down is because there's this little gotcha thing here. So you can either trace over this profile and set it active to eliminate this extra line, which I'll do real quickly, or you can actually do a line from the, you can actually create a profile from the model. Maybe I should show that as well. So let's say that I'm going to go back to the profile for this element, which is errant. And I want to essentially make the profile to go from this point here around to that other side. So what I can do is just do a line between points, and then I can actually pick a point right here in the model, and it knows where it is in this view. And then if it will let me shift around, I can pick the other point on the other side, which would be here. And obviously that's not the right point. So let me just do a line between points here. And I can pick this point, and I'm pretty sure it's going to go to that point, or pretty close to it. And once you have that, then I'm going to delete this one, set this one as the active profile, and I still have to adjust that one corner, but this side is setting on there right. So then you can pick this line here, and if you grab it, you might be able to pick this point here, or actually I can just adjust it. The other thing that you can do to modify that or edit it, I'm just showing you a couple other tricks. If you go to just a normal place line tool and snap to this in this view, snap to this point, you're going to see down here the elevation, the Z elevation, 34, 60, 56. If I snap there, so I could come over to this view and I could change this to 30, 54, 56, or 34, whatever that value was, 34. I should have memorized it. Let's see. Try that again. $34, let's just call it 3461. And that adjusts it right down there on the surface there. Now, as far as adding this gapped area here, obviously it's based on the template processing, so what you can do is add key stations to close those gaps. So if you go to the key stations, you can select the corridor model. Again, I need to turn on these. And then zoom into here and get a location as close as you can to the end of that radius point. What I'll do is I'll just kind of eyeball it right here, and then I can move that key station to get it closer. The corridor will reprocess, and it'll close that gap up a little bit. And there's still a little gap in there, and so what I would do is go edit that key station value, and now I'm getting the details of that nose in there as well. Now, it doesn't clip out the pavement. The pavement and the traffic separator both exist there, but for creating your finished grade surfaces and your bottom grade surfaces, this will give you all the line work that you need. As far as the cross sections, if you want the cross sections to look exactly correct through that nose, you would have to clip out the corridor in order with the nose properties. So that's how you do a traffic separator. As far as doing, you know, the nose on the end of these other curbs, you can use a linear template to do that. But first you would need to do the same thing. You would need to create a profile for that element. And in order to do that, I'm going to use the 3D view here. What I want to do is see this point and that point. So what I can do is, I'm hitting the fit tool here. I'm just going to lay one out for this corner over here. I'm going to select this line and go to its profile. And for now, I'm just going to draw a line between 2 points. And I can snap to this side, which is one edge, and I can snap to this side, which is the other edge. And then I'll use my the little trick I just showed you to like snap to this point on this view, get the elevation. So this is going to be 30.8 basically, and this is on the, when I go to this view, that would be this side over here. So and then that sure didn't seem right. Not paying attention here. Yeah, that's right, 30.8. And over here is 31.59. Let's say 31.59. So then in this view, yeah, I guess then this should be 31.59. It's just that existing ground that was getting me. And I'm not seeing that in the model, that it cuts actually right through there. Once I have that, I can just go and use the set active, and I should get a line that goes across there, and you can kind of see it in there. Actually, you can't see it. But once you have that profile, then you can use the curve component in the to place a linear template. So I'm going to place a linear template. I'm going to select the element to apply it to, would be this one. And then the template I'm going to use, if I Alt down, I've got an inside curve here that I'm going to use. And then I'm going to start it at this station and end it at the end there, and go to the inside with a sweep angle. And now you see I've got that curve in there. And so my crossover is not quite correct, obviously. And the other thing is that because the corridor, it basically stops at this point back here, I'm not getting that little extra gap there. So there's a little additional modeling as far as that goes. But I mean, that's what you're going to do for the noses. And again, on this one here, I would also want to put in a key station close to the end there. So I'll go to the key stations here. And sometimes it can be a little tedious as far as adding this extra detail, but I mean, it's all in how much you want to have it in your model. So I'm just going to place a key station here. And then because of the way it's trying to cross over, I probably want to move this point so that it's really, you know, off to this same distance over here. So I'm just going to move this over here and let it do the crossover there. Not coming out that clean, but I'd have to look at the details of it. The other thing is you want to make sure that you don't use any of the nose elements as corridor references, because you don't want the normal template to use these lines. Like now this one is using the edge of pavement line to draw it up to here. And then the same thing with the curbs that trigger on the curb median components. Now I've spent some time detailing out another intersection, so I'm going to open that up. But before I do that, I did want to show the civil cell to place a restricted turn lane, just so you know that it's out there. It doesn't work with this median because the median's only 24 and the restricted turn lane is set for a 40-foot wide, I think a 40-foot wide median. So you can't put a restricted turn lane in a 22-foot median, but I'm going to lay it in here just to show you it's not going to work. But so the first thing, when you go to it's actually in the intersections also, and there's a directional median opening, and this is based on the first index detail sheet, and the other two are basically for wider trucks and wider medians, but this one can be adjusted to accommodate for those as well. It's just a matter of changing the dimension offsets. But I'm going to go ahead and place this one just so you know how to place it. And it asks you for the left side road center line. So that would be this line right here, because that's to the left of my corridor. And then it wants to know where the right side road center line. It happens to be the same, but they need to be two separate elements. And then it asks you for the center line of your main roadway. So that would be my main center line. And it will, based on those three references, it will place the geometry for a restricted turn lane based on a 40-foot median. So I'll reset and accept it. And now you have that, and obviously it's being placed on a curve, and everything is curvature, curve linear, if you will. And then all of these blue lines, you'll see there's blue lines here, and there's also blue lines where the traffic separator are. This is how you can adjust this this civil cell. So let me just click on one of these and see how this is set to a 20-foot from the center line for the median width. My particular project only has 11-foot median, so this isn't going to look right. As a matter of fact, it won't even fit in there. But I just want to show you that I can adjust one and the whole civil cell will adjust itself. I could do the same thing on the other side. I'd select this outside lane, and that is the total width. So this would be minus 11. And this is, eventually it's going to break here, but obviously there's not enough room in here to put in a car, so that's why, you know, you can't fit this one in there with this wide of a curb median and then putting that in there. But that's why I wanted to open up this other file where one of these was actually placed and modeled. So let me do that. Let me open up this this other design file here. And I want to reiterate the steps for the restricted turn lane. So once you have the corridor, you're going to first need to do the corridor detail modeling where you put the crossover slope break lines and modify your template, add them so that you actually have the rollover happening without any of the line work for the restricted turn lane. And then you're going to add in the restricted turn lane. I used a civil cell. If you want to draw them yourself, you're welcome to. You're going to create profiles for the elements, and I'm going to show you those. You're going to use the curb linear template along the two sides where necessary, and if you need to add the flare outs, you can do that as well. And then you'll do the same thing with the traffic separator and add a point control to basically control the width and the elevation of the traffic separator. I'll show you that as well. And then you can use the civil cell for the traffic separator nose and of course clip those out. But when you're done with that, this is what you'll end up with. As you can see over here, first of all, I wanted to show you this little flare out. You can see the traffic separator has been drawn in there, and then these are two civil cells with a terrain in between them. And obviously I put the crossover in there first. Now let's look at the plan view. So let me go to two views here and show you some of the information. So for example, once I placed that in there, then I had to come in and actually get the profile for this line. Now the lines that come in with a civil cell are basically individual lines, so you would need to complex those together on each side. The traffic separator lines come in as individual, and you want to just leave them. You don't want them to be a continuous complex around the nose. You just want them to be individual elements on both sides. So once you have these chained together, then you're going to open up the profile for them. And then this is what I was saying about the profile from Surface Tool. There's obviously still a bug in it. In SS4 they said they were going to fix it and it was going to work off of the existing or whatever the top surface was that you were trying to get the profile from, but it still is doing this where it goes from one surface or one component to the next. In this case it's going from the pavement surface to the base to the pavement to the base to the pavement, and it keeps doing that, which is a bug in the software. They know about it. So all I do is go ahead and place a vertical profile with my vertical PVI tool in order to approximate it. And this is okay because then I can adjust it when I need to for whenever I need, like where the model starts bleeding into my curb. All I've got to do is find that location, and obviously this is going to be like right in here. That's where that's happening. So all I'd have to do is just take this and modify it, and I could adjust that profile. Actually, that's the one on this side. And that's because I was changing these lines a little bit. Once you have those profiles for those elements, then as you can see, they're just linear templates. And I can actually look at the linear template. It's nothing more than just the curb component. And it's being placed to the inside. You'll do the same thing on both sides. And then when you get that, you'll have two lines on the top of the curb. You'll have, here's one right here, this top line that you can select right here. And you'll have one on the other side as well. If I can zoom out of here. There's actually one on the other side right here. And then you'll just use those two lines to create the terrain, and then use, in this case I used the pond terrain and then I modified the element template for the pond terrain. So how do you do that? Well, like I said, if I were to go to my Project Explorer, I'll see that I have in here a terrain. If I go to the properties, it's using this proposed pond, and that happens to be this grass median across the top. So in order to make that look like grass, what you do is you go to the element templates, and you can modify the triangle display for a pond terrain. I'm just using proposed pond. And what I did is I went in here to this calculated features, which is how things get drawn. So I went to the triangles, and I changed this to shoulder unpaved PX. And it went from blue triangles, which is what we normally have, or green triangles, to an actual material level triangles, if you will. So it's shoulder paved. It's still on pond PX, the perimeter of it is. And I could have done the same thing if I had made it a proposed, but then all my proposed surfaces would have grass on them, and I'd like to leave those blue. The traffic separator was just a matter of getting the profile from surface on one side and the profile from surface on the other. And yes, I had to actually build those because the profile from surface tool doesn't, actually, I think it worked pretty good on these lines for some reason. Actually, it did. You can see this is the profile from surface. I don't know why it doesn't work on arcs, but I think it works on tangents okay, as long as there's just one surface. But whenever there's an arc like this, it wants to do that jig-jag thing. And then I just placed a linear template along one side of it and used the other side as a point control for that particular point. So if I go to this template, you'll see that it's just a traffic separator template, and I've placed it along this point here, the linear template that has a profile, and then I use this point for the point control, and you'll see that this whole thing will reshape itself no matter where it is. So if this is a different width, it will change it. If it's a different height, the slope will modify, so that you'll get a true representation of the traffic separator in a super elevated condition in there. And then the traffic separator nodes, which I've already demonstrated. And then this little flare out is just a matter of breaking this, having another separate element here, an edge of pavement element here, and placing the curb template along it and using these two lines as corridor references. So if you look at this, if I go to this template, you'll see that it has the corridor references turned on for it, whereas a normal curb type E doesn't. So this point right here is looking for curb face, and this point here is looking for curb back. And it also has, I added this label in here for height back, so that if I wanted to lower it, I haven't done that in this detail. If I wanted to make this taper down to 0, I could just add a parametric constraint to this corridor. And actually, I think I would need to make it a corridor, which is why I didn't do it. You can add parametric constraints to linear templates, but you could build this as a corridor and then add the parametric constraint to actually lower this curve down, taper it to 0 if you wanted to. But I've just left it as a type E flare out there. And it details out pretty good. There's a sliver here that I haven't quite figured out, and I didn't model out this nose yet, but essentially that's what you get. And then as you open the cross-section view for it, it's going to reprocess the corridor. While it's doing that, let me go check on any questions. I'm going to restart it because I do want to show this. Well, I did want to just open up these cross-sections real quick just to verify some of the details that are happening there and some that aren't. The particular thing I wanted to point out is it hasn't been clipped yet, and I'll show you what it looks like when it hasn't been clipped. Obviously, it's just going to show both components in there at the same time. So I'll just do locate via data point, pick the corridor, and I'm going to key in a station somewhere over in here. 1259.60, enter, and then open up view 4. It's going to regenerate the corridor at this point. So this is where, obviously, where the traffic separator, this is where that one little sliver was. If I just go back, it looks a little better. There's the other sliver piece. These are exact cross sections. So this is where it's like right in between the two here. So you can see there's this is where the actual restricted turn lane is in here, where it's actually laying in there correctly, but it's not cutting out the pavement. And you would need to add in these boundaries. You can actually place a boundary, if you will, shape around there and cut that corridor out. It just adds additional processing time. And if I just go backwards, I'll see, I want to get into this traffic separator with the curbs here. You see the same thing is going on with the traffic separator, but it's actually placing it in there, location it, so that you could have the top lines of your model. And of course, there it is on that side. So, you know, in the past, we've tried to do this with a single template and a whole bunch of different components turning on and off. This way, part of it's being done with a template and part of it's being done with detail modeling using the crossovers. And then, of course, you'd want to go in and check some of these slopes. This is a location where I actually added inserted these vertexes on these crossover slope lines so that I could get this transition from where the 2% goes up and it's kind of flat across here to the 2% up on the other side. And it just helped with the breaking of this, of where this transition was in the middle here. So these are some of the techniques that you know, we've developed for building the crossover details, so that number one, it gives you a realistic model and gives you the ability to not have to draw in that information with the by hand in cross sections, which obviously we don't recommend. You know, if you wanted to modify this slope in the middle, you could just add a break line across the middle of this line here and then profile it in order to make that work. Is plateauing similar? That's a good question. If you want to plateau an intersection, essentially what you're going to do is you're going to use a parametric constraint, and that's probably easier to show in this other data set. Since I actually have an intersection out there, it processes faster. The easiest way to do that is to put in 3 parametric constraint lines. One that transitions up, one that, like in this case, for this intersection right here, if you wanted to transition this up to, instead of being this cross slope across here, whatever it is in super, what you can do is go into the template and look at what that cross slope label is. All right, so let's see. It's in the wrong template library, so let me open up this, because I'm in the other project. Let me open up the project template for this. So this is the State Road 61 template, and what I'm saying is this point right here is the normal slope that you have on there. And it has a slope label right here, which is the left out slope, or the slope out left. So in order to override the current slope in there, now I'm questioning myself because of the fact that it already has a point control on there for the super elevation. So I don't think I can override a super elevation control with a parametric constraint. But if it was in a normal crowned condition, all you'd have to do is go into, let's just do it up here at this location where it's in a tangent. I think it's out of the super up here. So I could come into the parametric constraints, and let me turn on these boundaries, locate the corridor, and then I could give it a start location to transition up. So let's just do it from here to here. And then the label is what I just looked at in the template. It's the pavement slope out left. So I'll just have to find it. EOP slope out left. And you see that its default value is 2%, which is where it is in normal crown. So then you could you could do it within this range. You could say go from 2% to 0 and place it in there. It will reprocess the corridor. It will adjust it up there. You're not going to see it in the model. It's easier to see it in the cross section. And then once you have it in there once, what I do is I just copy and paste it. So once I have this parametric constraint in here once, then I just select it, choose copy, and then paste it in there again. And this time I'm going to unlock it so it won't process it. And then I can come out here and I can change this value. So I'm going to set this value to be the same as the end station. So I'll just do Control C here, Control V there. Doesn't like that. Escape out of that. Actually, the easiest way is to come here, Control C here, and come to here, Control V. And then for the exit station, I'll just tell it to go using this data point. It's going to go to here. I'm just eyeballing it so that I have a different end station. And then I'll just say that this goes from, this is where it's going to be 0 across there. And then I can select this one, copy it, and then paste it. And I'll get the third entry here. And then obviously I'll do the same thing. I'll take the end station, Control copy, make it the begin station of this one. Control paste, select the end station here, and then go select the point out here that I want it to transition back. And then I select this third line, and I set it to go from 0 to 2%, or whatever the first one was, yeah, 2. And then once I've got them all in there, I can lock it. It will reprocess the corridor, and now I've plateaued that intersection using parametric constraints. I didn't have to worry about super elevation, but there is a hierarchy in point controls, as you've probably heard in some of the training classes, where super elevation takes over control ultimately, and then point controls, and then parametric constraints, and then, you know, there's a whole hierarchy of it. In what views will you place the text for cross sections? If you mean just where I'm doing the cross slope correction checking, if I go to a corridor view here and then open up this cross section view, I can place temporary dimension lines to do cross slope correction checks. And I'm going to go to locate via data point, select this view, and I want to cut a section essentially right along the middle here in this view. You'll see now that this roadway has been plateaued up to 0, which is what I was pointing. And if I want to validate that, then I can just go to place temporary dimension line, and as long as it's a corridor cross section and not a cross section view, you can see I'm in the transition here. So if I step along, it's going to basically go, it's where it's transitioning back down to 2%. Let me do the center on current offsets. Yeah. So you see that it's transitioning back to 2%. If I go backwards, I've just plateaued that up with those parametric constraints. Now you can't do that. Well, it looks like this is where the super elevation was still in transition. So the super elevation control is what overrode even my parametric constraint in there. You'll notice that there's a red magenta box on this point. That is a point control, which is the super elevation control. And then as I get in here and the super elevation transition limits itself, it should change to a green box. Or else it's still in super all the way across there. That's what that is. Usually parametric constraints will be green. So let me just turn on the supermodel real quick in this view. It's probably transitioning, but that's the, if you didn't have a super elevation, that's what you would do. Yeah, it's still transitioning down. If that last question is about placing text on cross sections like annotation text, then that has to do with actual production cross sections. Right now, this is just design. This tool here is what creates cross sections that you plot, and then once you've plotted, you can add in all the annotation that you need with some of the other tools. And that is covered in the Plan Production Chapter 5 or Plan Development Chapter 5 webinar. If you go to the, let me just go to home here. If you go to the ECSO's posted webinars out here, in the plan development workflows, there's a whole chapter dedicated and a whole webinar that was done on cross sections and sheets, and it covers everything from ancillary features to annotating and labeling them to basically everything. Once you've created your design cross sections, then you can use this webinar to basically produce them according to what you want to plot out. I think I might have run over. Yep, run over by about 10 minutes. So thank you all for hanging in there with me. Feel free to call us if you have any questions, and we'll go ahead and stop today's recording.